Look at 2017 number 3. The function f is differentiable, and then as you can see we have graph of f prime given here. And then we know that f of -2 equals 7. And then 3-line segment, and then a half circle here. Then once you find f of -6, how would you do it? You see, they gave us f of -2, and then I want to compare that to here. So one way which we can do is f prime of x dx from -6 to -2. This in fact is equal to f of -2 minus f of -6, and this is by fundamental theorem of calculus. And then to find f of -6, then is equal to f of -2 minus integral from -6 to -2, f prime of x dx. Now, f of -2 was given to us as 7 minus, and then this second portion is the area of this triangle. You see, when you look at the base becomes 4 units from -6 to -2, 4 units, and then height is 2 units. So the area becomes 4. So therefore, our final answer becomes 3. Now, second, we want to figure out f of 5, and once again, starting from -2. What I can do is integral from -2 to 5 of f prime x dx will be equal to f of 5 minus f of -2. Then you can see that f of 5 should be equal to f of -2 plus -2 to 5 of the area f prime of x dx. Now we realize that f of -2 was equal to 7 from the question. The second one is we have to get the area from here to here. And in this case, you can see that this is half of the circle where radius is 2. So then, since the radius of circle is 2, then we get pi 2 squared, but because it's a semicircle, we're going to divide that by 2. But we have to realize that since this area is under the x-axis, we have to get that negative. Now, how about second one? Base is equal to 3, height is equal to 2. So the area becomes simply 3. So in other words, -2 pi plus 3 is the area. So when you combine them together, we get 10 minus 2 pi becomes f of 5. Now, B, on what interval is f increasing? F is increasing when f prime is positive. Where do I see f prime being positive? Going from -6 to -2. So first -6 to -2, but -2 is at 0, so I'm going to have that as an open circle. And then over here. Or a second one is from here 2 all the way down to 5. So in these intervals, we realize that f is increasing. Now let's look at part C. Find the absolute minimum. In order for you to find the absolute minimum, what I'm going to do is I'm going to make a table. Endpoints of -6 and then 5. And then the other intermediate points has to be the critical points. So here, when they pass through the x-axis, which is -2 and then +2. And f in this case was 7. F of negative 6 was, we figured it out as 3. F of 5, we figured it out as 10 minus 2 pi. How about f of 2? F of 2 was after losing the area of the semicircle, which was 2 pi. So we get 7 minus 2 pi. Actually, I forgot about 2 pi here. And when you look into these values, which one is the lowest? Minimum value, absolute minimum value is right over here. That's the lowest because 2 pi is about 6.28-ish. So this would be our lowest value. So we get absolute minimum is 7 minus 2 pi at x equals 2. Alrighty, let's look at part D. For each f double prime of negative 5 and f double prime of 3. Now f double prime of negative 5 is right over here. Since this is this graph is f prime, f double prime of negative 5 is slope of f prime at x equals negative 5. So then when you look at it, slope seems to be going down, and change of y is negative 2, and then change of x is 4. So we realize that the answer is negative 1/2. Change of y over change of x. How about f double prime of 3? F double prime of 3, we see a corner. So therefore, we can say dne. One way for you to say that is because it's the corner, you can say that. Or another way for you to say that is, after all, slope is the limit. Slope is the derivative at this particular point. So limit of f double prime of 3 not 3x. Well, let me just put it this way. F prime of x minus f prime of 3 over x minus 3 as x approaches 3 from the right side is not the same as f prime of x minus f prime of 3 over x minus 3, x minus 3, that. As x approaches 3 from the left. The slopes are not equal to each other. That's basically what they're saying. Therefore, dne as well. All right, with that one, we are done, and I'll see you later.